A boat leaves Miami and travels a course with a bearing of 75 degrees. The boat maintains this heading for 1 hour and 20 minutes, traveling at 35 knots, which is nautical miles per hour, and then changes to a bearing of 145 degrees. The new heading is maintained for 3 hours 15 minutes at 46 knots. At the end of the second leg of the trip, the boat is to return to port. So let's draw a diagram. And what I would like to do is not only draw the diagram, but answer B, answer C, and then maybe we answer D as well. So let's try to knock out A, B, C, and D as we're drawing the diagram. So to start the diagram, we draw a north-south line, and we have to start somewhere. Let's say we start here. And this has to be 75 degrees clockwise from north. So let's say this is 75 degrees right there. Let's find out how long that should be. In order to do that, we're going to answer letter B. And the first leg of the trip, we travel 1 hour and 20 minutes traveling at 35 knots, which is 1 and 20/60ths, because there's 60 minutes in an hour. We're going to multiply that times 35. We're going to do that on the calculator. So we have 1 plus 20 divided by 60, which is 1/3, then times 35. And on the calculator, we get 46.667, which is 46 2/3. Let's store that into, let's say, letter A. So we'll call this A, and we've stored it as 46.667, but on your calculator it shouldn't be rounded. It just has a bunch of sixes, and at the very end it's 7. So I'll store that into alpha A. Letter C says, what is the distance of the second leg? Well, we haven't drawn the second leg yet. There's north-south line, and we need to draw this 145 degrees clockwise from north. But I'd like to get a length that represents how long it should be. So let's answer letter C. What is the distance of the second leg? On the second leg of the trip, they change to a bearing of 145 degrees, and new heading is maintained for 3 hours and 15 minutes at 46 knots. So we want 3 hours and 15/60ths times the 46 knots. We'll worry about the angle here in a second. So we have, on my calculator, 3 in parentheses, 3 plus 15 divided by 60 in parentheses times 46. So we get 149.5 miles. Now I'll store that into, let's say, B. So I need 145 degrees, and it's much longer than the previous one. So let's say that is 149.5, and we've stored that into B. This angle right here is 145 degrees. So there's not quite A, B, and C, because we have to finish this out, and they have to go back to port, so this is the vector that represents going back to where they started from. Letter D said, what is the measure of the included angle between the first 2 legs of the trip? They're asking us to find this angle right here. Now, if this right here was, let's find out what that was. What angle was that? That was 75 degrees. So by alternate interior angles, this one is 75. And if this is 145 degrees, then the remaining must be, let's see, 35 degrees. So that is 110 degrees. So the answer to letter D, what is the measure of the angle included? 110 degrees. What is the distance back to port? Well, we can use the law of cosines because we have the 110 degree angle and we have its included sides. So we have the distance equals a squared plus b squared, because we stored those values into a and b, minus 2 times a times b times the cosine of 110. So I'll do that on the calculator. So we have a squared plus b squared minus 2 times a times b times the cosine of 110. That's 29,300 and some change, so I'll have to take the square root of that. Square root of the answer is, and what I get is 171.173. 171.173. And that's miles. And I'll store that into, let's say, C. What will be the bearing to return to port? Now, if I draw a north-south line right there, I need this angle, which is going to be past, looks like, if I drew it somewhat accurately, is going to be past 270 degrees. Well, if this right here is 145 degrees, then I know that this to here is 145 degrees. And I think if I get, well, if that's 145, there's 145. This right here must be 35 by alternate interior again. Now, if I can get theta inside here, inside the triangle, I'm pretty sure I can find out what this angle is right here. So we have A over, that's the 46.667, A over the sine of theta, that's not a variable, we know what that value is, equals, let's see what else can we use. We have, what did I put that in, C? I think I put this in letter C, which will be C over the sine of 110. And I can find out what angle this is in the triangle. So we have sine of 110 times A divided by C, and then the inverse sine of that answer, which, so theta is 14.844 degrees. Now see if we can figure out what this angle is based on all this information. So if we know that this angle is 14.844 and we know this one is 35, we can add these two together. So we have 35 plus 14.844. These two added together is 49.844. Now that's this angle right here. Now the rest of it from right here needs to be 180 minus the 49.844, and what you get from here to here is 130.156. But I also know that from here to here is 180 degrees. So there's the angle. This plus the 180 should be the bearing. So we add 180 degrees, and the bearing from north going clockwise is 310.156 degrees. So 310.156. In G, it says, what must his speed be on the final leg if he must complete the total trip in 8.5 hours? Well, if we take 8.5 minus, in the first leg, he's gone 1 hour and 1/3, so 1 1/3 hours. And then in the second leg of the trip, it took 3, and that's actually 1/4. 15 minutes is 1/4 of an hour. So 3 1/4. So let's see how much time he has left out of the 8.5 hours to get back. So we take 8.5 minus 1, this is in parentheses, plus 1/3 minus, in parentheses, 3 plus 1/4. So it's 3.91666, keep on going. So that's how many hours he has to get back. Well, to calculate speed, it's miles per hour. And he has to go C miles, or 171.173. So to get the final answer, we're going to take C divided by the answer that's sitting in the calculator, which is this number. So we have alpha C divided by the answer, and he needs to average 43.704 miles per hour, and that's nautical miles.